Big O notation is used to compare programs, algorithms, and data structures. Big O notation measures the order of the function, which means how quickly does something get big. We write Big O notation using an uppercase O and then an equation in terms of n. N stands for the number of items. Something that grows with n squared is going to grow faster than something that grows with just n. To keep comparison simple, we only keep the fastest growing term. These simpler expressions are easy to compare since we can plot the graph and immediately see which one grows faster. When Big O notation is used in computer science, it generally measures either how much time or memory a program takes. So a program with time growing in O of n squared will take longer to run than a program growing in O of n. Likewise, a program with memory usage growing in O of n cubed will take more memory than a program growing in O of n log n. Big O notation is useful when talking about data structures and algorithms, which form the building blocks of programs. A lot of details can change exact runtime metrics, such as the compiler or interpreter used, how the code is written, and the hardware being used to run a program. What Big O notation does is it removes all of those details and gives us a simple, unified method for comparing and discussing algorithms and data structures. This simpler view allows us to see the underlying trends of how our algorithms behave rather than get focused on the implementation details. There are some flaws with relying on Big O notation too much though. Big O notation doesn't tell us how well a program will perform. It only tells the time and memory usages of a program as our data set grows. In practice, for small amounts of data, it can be faster to use a slower Big O notation program. Yet for large amounts of data, it will be faster to use our faster Big O notation program. In these situations, there is a crossover point where both algorithms perform about the same. The crossover point allows programmers to do algorithm switching, where they switch between the two algorithms based on the number of items being processed. I've used Big O notation to understand why my program is running slowly, determine how and where to focus optimization efforts, and to understand why some best practices exist and how they work.